Okay, lads, I'm just going to go through those 4 questions I put up today on Thursday. So the first question was calculate the length of the line segment. So we just want the length between these 2 points, and I personally always like to just sketch what's going on. So -1 and 4, so this must be my leftmost point. So I'll go, that's -1, 5. And now do I go up or down to go from 5 to -7? Well, I go down. So this is going to be 4, -7. So the line segment should look something like that. Only really important if you're finding the gradient, but I can now create a right angle triangle like that. So the length of any line segment can be seen like a hypotenuse of any right angle triangle. So we basically want our difference in x squared plus our difference in y squared, and we want to add those in a square root, just like Pythagoras. So the length of this line is, we label this x2, y2, and this one x1, y1. So it's going to be x2 minus x1. 4 take away -1. We square that, plus y2 minus y1, so -7 take away 5, all squared, and then we square root that. So it's just a more of an abstract way of looking at Pythagoras' theorem. So here we get 4 plus 1 is 5 squared, plus -7 take away 5 is -12 squared, and that is all square roots. So it should give us 13. The reason I got to 13 so quick is because I've realized that is a 5, 12, 13 right angle triangle, which is a special kind of triangle. So let's have a look. 5 squared plus 12 squared, and then square root that is 13. So 13 units long that line is. So just a quick recap, we took the difference in the x's. So we took this distance of 5 and squared it. We took this distance here of 12 and we squared it, and then we square rooted both of those, added together, and we got our total length. Okay, calculate the gradient of this line segment. So again, this is the leftmost point, so I'm just going to go -8, -2, and this has gone across and up. So our line is looking like it's going to have a positive gradient, 324. So gradient is rise over run. Now rise is the difference in the y's. So 24 take away -2. So this number take away this number over the changes in x. This number take away this number. So 3 take away -8. So that's going to be 26. And this is going to be, is it 26? Yeah, 26 over, and that's going to be 11. So our gradient is just 26 over 11, or if you put that into calculator, about 2.4. 2.4 is the gradient, or I'd just leave it as 26 over 11. Just going to check that again. So I take the difference in the y, so the y2 minus y1, okay, 26, and 3 take away -8, yeah, is 11, okay. What is the perpendicular gradient of this line segment? So it looks like this is going up and to the right. So if I was to draw this, it would be 5, 7, up to 8, 16. So we're trying to find the gradient of that. So gradient is 16 minus 7, because that's the difference in the y, change in y, over the change in the x. 16 minus 7 is 9, and 8 minus 5 is 3. So we have a gradient of 3. We want the perpendicular gradient. So the perpendicular gradient is -1 over 3, because Negative 1 over 3 times 3 is negative 1. Remember, perpendicular gradients multiply to be negative 1. So if you want a perpendicular gradient, just flip the fraction and then make it negative. So instead of 3, we've got 1 over 3, and it's a negative. Now we want to prove that these points are collinear. So I'm just going to sketch. They should be all in a line. So negative 2, 8, 1, 2, and 8, negative 12. Well, if the gradient from this point to this point is the same as the gradient from this point to this point, then we are collinear. So let's go A, B, C. Then the gradient of AC is going to be the change in y, negative 12 take away 8, difference in the y's over differences in the x's, 8 take away negative 2. And so that's going to be negative 20 over, and that's going to be negative 10. So we get a gradient of 2. Now the gradient of AB is doing the same thing, difference in the y's. So 2 minus 8 over 1 take away negative 2. So 2 minus 8, that's negative 6 over, and that's 1 plus. Let's have a look. So 2 take away 8, it's negative 6. 1 take away negative 2. 1 take away negative 2 is 3. So I've got negative 2. Have I done that wrong? It should be the same. Oh, here. Yeah, negative 2. That should have been a positive. So negative 12 take away 8. It's negative 20. But then I've got 8 take away negative 2. And that's positive 10, not negative 10. So yeah, the gradients, this gradient and this gradient all the way through are the same. So the points are collinear. Nice.